Hey, this is Jesse with Create This. Today is Saturday, June 21st, 2025. My first video about this AI inference machine was back in March 31st, 2025. I was getting about 6 to 8 tokens per second with CPU only. Then I made a follow-up video on April 5th, 2025, where I was getting 14 to 16 tokens per second with ktransformers and a 3090 GPU. I ran like that for about a month and a half, something like that, and I started getting frustrated because ktransformers would crash all the time. I would run out of context because it was unreliable. I decided to bite the bullet and buy an NVIDIA Blackwell 6000 Pro. So this is a 96 gigabyte VRAM GPU on the Blackwell chipset. So close to a 5090 in performance as far as the GPU goes. No water cooler. It's just two fans that blow straight up. And one other change that I made is I have these Arctic P14 PSTs. So these are 140 millimeter fans. And so I've got 1, 2, 3 blowing inward, and then 1, 2, 3 blowing out. And then I've got one of the smaller fans blowing out this way. And that setup seems to work pretty well. It keeps everything fairly cool, and it's also pretty quiet. I had the max fans, the Arctic 140 millimeter max fans in here for a little while, and it was just a little bit too loud for me. So I like these PST fans. They're good. Yeah, that's pretty much it hardware-wise that's changed. This was a fairly simple drop-in, and you can see I've got like all of these power cables attached to it. 1, 2, 3, 4. Takes 4 PCIe connectors. So let's see how it performs. All right. We're on a fresh boot here, and this time I've taken the time to mic up with the good mic, so you're welcome for that. The audio was pretty abysmal in the last two videos. All right, so we've got a fresh boot. I've started a screen session. I've activated my Conda environment, and this is just what I use to build ktransformers and also llama.cpp. So I've switched, when I installed the Blackwell card, the Blackwell 6000 Pro, I switched to llama.cpp. And one of the reasons why I did that is because I have a lot more VRAM available now. And so llama.cpp is not as resource efficient as ktransformers was. I could run DeepSeek v3-0324 with full 128K context under a 24 gigabyte 3090 under ktransformers, but I couldn't do that under llama.cpp. So I can do that with the Blackwell card. So let's just go ahead and start up a version here. We'll go with, you know what, let's go with R1-0528 because that's the latest. The first thing that I do is I do these NUMA balancing and drop cache things. And this just helps prime the environment so that there's no cached memory laying around. And then I take this long line. I'll go ahead and explain some of these things. So this is the path to my gguf model files. I've got an alias for the model itself, so I'm running R1-0528 Q4KM. No web UI, I don't need that. I'm running a different web UI. I do this numactl thing, and this allows, I guess I should back up for a second. So one of the things in the last couple of videos is so this is the IPMI interface for this motherboard. There's a BIOS setting here. So I can go into the BIOS and you have various NUMA. NUMA is like how you control memory access across dual CPU or multi-CPU environments. So you can go in here to performance, and there's this thing called Actually, maybe it's not in performance. Hang on. It's been a while. Yeah, DF common options and then memory addressing. So there's this thing here called NUMA nodes per socket. And so this just allows you to define how many regions are available per CPU for memory isolation, I guess, like to avoid caching memory in and out. So for the last two videos, I was using NPS 0, which is basically the motherboard controls it, and it just sort of defines one NUMA region for both CPUs, and the performance you get is what you get. You've got like no control over it in user space or kernel space or anything. So what I've done with llama.cpp is I've switched this over to NPS 4. So now I have 4 regions per CPU, so a total of 8 regions available. And what that does is it allows me to use numactl here in the startup options. And it just basically gives me about 4 tokens per second extra in inference. So it helps. And then I defined 32 threads. So I tried 60 threads because I've got like 64 cores available on these CPUs. Maybe we'll try this with 60. That might be necessary. So with NPS 0, I was using 32 because if I used more than that, it didn't matter, just because of the way NPS 0 works. But with NPS 4, I think 60 is actually the correct number. So anyway, context size, I believe this is 168K. It says 163. Llama.cpp will complain. It'll say that you're not utilizing the model fully for R1 and also V3 unless you specify 163K. So this is just your context window size. So I guess they have about 168K available. I don't know. I don't know if that's a typo or what. I've heard it quoted as like 128K. Other places say 139, you know, like, but llama.cpp seems to think that it's 168 or 163 or whatever. So this is the number of layers that I'm offloading to the GPU, 62. Seems to be arbitrary, something about the architecture or llama.cpp, I don't know. The rest goes to CPU. I start up with this seed 3407. I think I could choose a random seed if I wanted to, but I just do this. Priority, this is like the thread or the process priority within the scheduler. And then these are things that are specific to the model itself. So these are settings specifically for R1-0528. Log colors, turn on flash attention, you know, use the whole machine so that other things can access it, and then the port. So let's go ahead and run this with 60 threads, and we'll see what kind of performance we get out of it. And while I'm doing this, just take a look up at the top. So I'm starting at 4:51 p.m. and you'll see how long this takes to load. I think it takes about 5 minutes, could be a little longer. All right, and at 4:54, we're all loaded up. So let's switch over to OpenWebUI. We'll do a new session, reload it, and we'll say, howdy, partner. So llama.cpp isn't quite as nice as ktransformers as far as its output goes. It's a little more difficult to grok what's going on. One of the things that I used to like about ktransformers is that it would write the output here as I was, you know, as the model was generating it, and llama.cpp doesn't do that. So in OpenWebUI, you can see the thought process that would have streamed if I were paying attention to it, and it gives you something. So let's do write a poem, and this time we'll take a look at it as it comes in. All right, so here's our thinking. You can see how fast that goes in real time. And then there's our response. And as he's doing that, you can see in NV top, we're using about 36 gigabytes and 62% of the GPU. Pretty typical. And in top, we're using about 375 gigs resonant for the Q4KM-R1-0528 model. So as far as tokens per second go, this is at the very beginning of the context, and we're getting, you know, roughly 16 for prefill and 22 for generation. So, and I see this bounce for prefill between 8 sometimes and 25, right? Like it goes all over the place. But fairly speedy, not too bad, right? Let's, yeah. Let's do V3-0324 now. So I just have these startup commands sort of in my text file because that's the easiest way for me to keep track of them because I change things all the time. I'm always experimenting. Let's do Q8 first. So instead of Q4, we'll do Q8. And again, I'll just clear the cache. And let's change this back to 60. I think that helps. It was a mistake I made earlier this morning. And we'll start up Q8, Q8O of V3-0324. So again, you can see up here, this one's going to take a little bit longer to load. So starting out at 458. All right, 503, and we're good. So let's switch back over to Open Web UI. Refresh the page. So V3-0324, Q8. So howdy, partner. This is a non-thinking model, or a non-reasoning model. They all think, arguably. All right, let's say, write a poem about cats, please. All right, while he's doing that, we can see that our tokens per second is a little lower, 16, 15, somewhere in there. That's because it's a Q8, so it's larger. We are up to 42.5 gigabytes of VRAM in use, and we're using about 62% of the GPU's processing power. Top, we're using 664 gigabytes of RAM out of the 768 available. So almost utilizing the machine completely, but we're bottlenecked on RAM throughput is what's going on. So we can't use the GPU fully because the RAM is not fast enough. We don't have enough megahertz on the RAM. So he wrote the poem, and we're pretty consistently getting between 15 and 16 tokens per second on V3-Q8. So let's go ahead and start up Q4, V3-Q4 KXL. This is my workhorse. This is what I use like 90% of the time when I'm doing tasks, agentic tasks. Again, wipe out the cache. Q4 KXL. And the start time is 5:06. We'll see how long that one takes to load. Okay, 5:09, and we're up and running. Switch over to Open Web UI, v30324 Q4 KXL. So I like the KXL because it's slightly smaller than the KM variant, but it performs just about as well in my experience. Howdy, partner. Read a poem about sentient lumps of rock. All right, and we can see that we're using about 36 gigabytes of VRAM and 65% of the GPU. Llama server's taking about 357 gigabytes out of 768 available. And yeah, we're still system RAM throughput bound. We're not using a whole lot of the GPU, less than half usually. So let's see, tokens per second, somewhere between 9 and 26 tokens per second. I think you'll find that it averages out at about 20, and 20 to 23 tokens per second for generation, which is quite good. That's good performance. I like it. This is definitely my workhorse model agentically, because it's kind of a nice balance between fast and smart, and it just works really well. So llama.cpp is extremely reliable, at least at this date. I'm running probably the latest commit, maybe, well, probably not quite the latest, but pretty close. I think I pulled head like a couple of days ago. So very, very reliable. Ktransformers, on the other hand, was not. So let me give you an example of the issues that I was getting with ktransformers, and we can kind of look through the differences between ktransformers and llama.cpp. So we'll just kill llama.cpp. We'll go into the ktransformers directory, and let's see which commit I have pulled. Okay, so this is head or close to head for ktransformers. And I'll go over to my notes here, and we'll start up the ktransformers backend. They have multiple backends. They've got a balance serve backend and a ktransformers backend. For agentic purposes, I really like the ktransformers backend because it has the fastest prefill available of any inference engine I've tried. Like, the cache is excellent. As long as you don't have multiple clients hitting the server, there's no penalty between requests all the way out to like your maximum context, which is kind of unheard of. Like, usually the further out you go, the more it reprocesses the previous, parts of the conversation, and it takes longer to respond. But the ktransformer backend doesn't do that. The balance serve backend does do that, so I don't really like to use it, but they've deprecated the ktransformer backend, and the balance serve backend is the only one that's supported now. So I'm going to show you a backend that they no longer support, because that's how I roll, because it's the one that I like the most. And I'll note that when I started this journey back in May or whatever, the balance serve backend was not out yet, so this is a relatively recent thing that they've deprecated it. All right, let's see if I can find my notes. So I think for this version, we can do the Q4 KXL v30324 variant with full context, and yeah, we'll see how that works. See if it starts up. I haven't started it up in a while. So starting up at right around 5:14 p.m. All right, and it's fully started at 5:15 p.m. Starts up very quickly. Let's do a quick query. Open Web UI, Q4KXL, howdy partner. And so here you can see that it sort of types out as it responds, and you get to see the responses, which I like. I think that's pretty cool. Write a poem about sentient lumps of rock. So you can see here in ktransformers, we're actually getting slightly slower decode, 18 tokens per second instead of 20, 22, or 24, or whatever we were getting before. But the prefill's way higher, right? We're getting like 80 prefill. So my feeling is that ktransformers is a lot faster, but let's show the crash here. Oh, and while we're doing that, just to look at the VRAM. So ktransformers is using about 20 gigabytes of VRAM, and not a whole lot of the GPU as far as, you know, GPU performance goes. Let's try closing down the ktransformers engine and starting it up fresh and see if that causes it to crash, because we did use Open Web UI first. All right. Let's send that same payload. And there we go. There's our crash. So we see there's a CUDA error device side assert triggered, and it gives a backtrace. There's a GitHub issue open for this error. They know about it, and they, you know, I think they want to fix it, but I'm not sure that they know how. So this is why I don't use ktransformers, because you'll just be chugging along agentically with ktransformers running, and 20, 30, 40, 50 K of context in, suddenly it just shits the bed, and, you know, it's dead, and you've got to restart it, and then you've lost all of that context. Whereas with llama.cpp, you know, I've had that process up and running for days on end, with agentic process after process after process fed through it, and it never crashes. So, and in fact, I've had OpenHands AI crash Docker several times, and llama.cpp is still running. So very cool stuff. I'm really a huge fan of llama.cpp, but you just have to realize it's not as VRAM efficient, right? Like, you're using 20 gigabytes of VRAM with ktransformers, and the same model uses like 36 gigabytes in llama.cpp for whatever reason. So something to keep in mind. I think if you really want to be cost efficient, a GPU, like a 5090 class GPU with about 48 gigabytes of VRAM would probably be ideal, because I'm not using over 50, you know, I'm not using over 48 gigabytes at this point, I don't think. Maybe that one Q8 was using close to it. But you could run some pretty good models with 48 gigabytes of VRAM. I could get better performance out of this machine if I had better system RAM performance. So let me show you a little bit of that. We'll shut down top and NVTop, and come over here to SPAC. SPAC is I don't know, it seems like a package management thing. I've never used it before, but AMD recommends it for using with the Stream Triad memory bandwidth test. So we're just going to run the stream Triad memory bandwidth test. And there we go. We can see that for the Triad test, we're getting about 723 gigabytes per second throughput. I've got 24 RDIMMs, so 24 channels, and my CPUs have, I think they've got a full 16 CCDs per CPU. I could be wrong about that. It's been a while since I looked at those specs, but they should be able to fully saturate the RAM bandwidth. But the issue is I've only got 5600 megahertz RDIMMs. It would have cost significantly more to get 6000 megahertz or 6400 megahertz RDIMMs, which is like the next step up. So if I wanted slightly better performance, I could buy 24 new 6400 megahertz RDIMMs, and that would help. But it would probably also be about $8,000 for like a terabyte of RAM. So for now, I think I'm probably just going to stick at this RAM performance level. It seems to be adequate for my purposes. Oh, there's one more thing that we can do. I know. We can do Qwen. So let's go back to llama.cpp. Oh, not dot dot. And let's run Qwen 3. So this is going to be Qwen 3, 235B, A22B, 128K context. And let's do this with numactl. I don't think I've run this one with numactl yet. And we're also going to wipe the cache before we run it, just to be safe. Flash attention is set, 60 threads, no web UI. Yeah, all of that looks good. Let's see what kind of performance we get out of this. So starting up at 5:28 p.m. All right, we're ready to go. It is 5:31 p.m. Let's go into Open Web UI, reload it, start a new conversation, Qwen 3, 235B, A22B, 128K, Q8. So could have done probably Q4, KXL or something, but I'm doing Q8. This is the thinking model, so we should see think tags. Here's our thinking. All right, and as it's doing that, we can look at the NVTop. So we're burning about 22.6 gigabytes of VRAM, 13% of the GPU. Top is showing 240 gigabytes resident in RAM, system RAM. And we're using, okay, so 61% of the GPU for processing. He's done. Write a poem about sentient rocks. And while he's doing that, we'll take a look at these stats. So let's see, it looks like 15 tokens per second. Kind of slower than V3, that's interesting. "14 tokens per second. Probably because it's a Q8 model. It's probably why it's slower than V3, Q4. Now, I don't use Qwen 3 with llama.cpp for agentic purposes, simply because I can't turn the thinking off. If there was a setting in llama.cpp, there's a GitHub issue open about this, But if there was a setting at startup level where I could turn off thinking, then I would probably use it. But because it's not there, I don't really find it quite as useful as the V3 model of DeepSeek, so I just use that instead. But still an interesting model. It's pretty cool. Again, roughly 14 to 15 tokens per second for the Q8, 16 to 40 for prefill or prompt evaluation. So interesting. All right, if there's anything else that you want me to do, if you're curious about anything else that this hardware will run, let me know down in the comments down below. If you like this content, go ahead and press the like button, subscribe, all of that stuff, smash the bell, whatever it is YouTube is doing these days. And as always, thanks for watching, and please subscribe.